Hi everyone, I'd like to begin today's lesson with this warm-up. So this says, in the summer of 1998, Mark McGwire and Sammy Sosa captured the public's attention with their pursuit of baseball's single-season home run record, which was previously held by Roger Maris. McGwire eventually set a new standard with 70 home runs, which was broken by Barry Bonds in 2001 with 73 home runs. The question is, how does this accomplishment fit Bonds' career? And to begin to answer that, I want you to make a stem plot of the data below and calculate the mean and the median of the distribution. Now, the first thing I notice when I look at this is that we have two variables here. We have the year and we have the number of home runs. Okay, and so what we're really interested in is the number of home runs. So I want you to ignore all this year data and just make a stem plot of the number of observations. In other words, the number of home runs, 16, 25, 24, etc., all the way over to this 45. Think of this as one continuous set of numbers. This is a skill you're going to have to develop, being able to look at a display of data like this and be able to identify what are the parts that are important versus what are the parts that are, extra. Okay, so I want you to take 5 minutes to make a stem plot and then also calculate the mean and the median. Please pause the video now. Okay, hopefully that wasn't too bad. Here is what your stem plot should have looked like. Remember, this 1 and 6 represents 16, 19, 24, 25, 25. Okay, I can already see that this 73 that we're talking about is a bit of an unusual observation, right? We might call it an outlier. We'll talk about those more again later, but I want to keep throwing that term out there. When it came to calculating the mean and median, for the mean, hopefully you added up all of the individual values and divided by how many there were. So for example, 16 plus 19 plus 24 all the way up to 73. And I believe there were 19 observations. So that gave you a mean of 37. By the way, for mean, we typically use the character X bar. It's an X with a bar over top of it. For the median, you can either cross off until you get to the middle, or I can show you a shortcut. If you know that there are 19 observations, that means the middle observation, well, you're going to take 19 plus 1 and divide it by 2, and that's going to give you 10. That means your median is not 10. Obviously, 10 isn't even anywhere near here, but your median is your 10th observation from the bottom. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In other words, that 10 has 1, 2, 3, 4, 5, 6, 7, 8, 9 guys on this side of it and 9 guys on the other side of it. And that 7 represents 37. So the mean as well as the median are both 37. Typically median we abbreviate with a capital M. We'll talk about those more later. So both the mean and median were 37 home runs. Now I'd like you to please take your graphing calculator out. If you are unfamiliar with the graphing calculator, that's okay. I'm going to start from the very, very, very beginning. Like really, literally the very beginning. So please, now that you have it out, take the cover off. And in order to turn it on, you see this little button by the bottom left that says on. You press that one, and now your calculator is on. So there's your first skill, taking the cover off and pushing the on button. If you would like to turn it off, you see that off is written, mine is in blue, yours may be in a different color, above the on button. And blue is my second key. So I'm going to hit second on, and now my calculator is off. Okay, so turn it back on, please. And the first thing I would like to show you how to do with the graphing calculator is how to make a histogram. Your calculator can't make every possible graphical display that you'd want it to make, but it can make histograms. So in order to do this, the first thing we need to do is enter this data into our calculator. And I'm pulling from the data that we used yesterday. I can make it a little bit bigger so that you can see it better. And so in order to enter that data in our calculator, I need you to hit the Stat button. It's right here. It's underneath the Delete key. I want you to hit Stat. And a menu pops up, and the first thing you have there is Edit. I'd like you to push Enter. And I'd like you to use the arrow keys so that your entry field is in list 1. If you have any numbers in list 1 already, okay, you don't need to do this if yours is blank, but let's say I have a few numbers in mine. Uh-oh, Miss Kramer, how do I get rid of these? Well, if you ever need to clear out a list, you toggle up so that that list is highlighted. You hit clear, not delete, but clear, and enter. And now that list is cleared. I'll show you what to do in a minute if you accidentally delete a list. But for now, just make sure that your list 1 is clear. All right, I'd like you to take a second and enter this entire list of numbers. I believe there are 19 numbers in list 1. So you're going to type in the first number, 195, and you're going to hit enter. And it enters 195 into your list 1, and it allows you to move to the next number. The next number is 212, and then enter. Okay, I'm going to do this so that you have time to do it and follow along. The order in which you enter these numbers does not matter. I know this is boring and awkward and quiet, but you need time to enter these numbers as well. If you're done already, double check. Okay. And you can at least check that you have the right number of entries, because my last number, 211, is going in as entry 19. And when I hit enter, it tells me now I'm on entry 20, which means 20 is the first blank one, which means I have 19. All right, the next trick I want to teach you on the calculator before we go into the histogram is that if you get scared, okay, if you end up in an unfamiliar screen and you're like, oh, I don't know what to do, you quit. Okay, so that's my lesson to you right now is if you get scared, quit. Quit is above the mode button, so you hit second, mode, and it takes you back to your home screen. So if you get scared, quit and go home. Okay, so everybody's back at their home screen because we all quit. And we would like to now make a histogram. So I'd like you to hit the second key and hit Y equals, which is the very top left button. You see that the wording over top of Y equals says stat plot. So we're going to hit second and then stat plot. For me, all of my plots are off. If they're not, this is only if you have some plots that are turned on, I'd like you to go to option 4, plots off, and hit enter, enter. And now your plots are all off. And we're not going to have any extra graphs that your calculator is trying to make. Second Y equals, so we're back on the same screen again. And I'd like you to enter into plot 1 and turn it on. If you hit the down arrow, it's asking you to choose which type of graph you want to make. You want to make a histogram, which is the one that looks like this. It's the third option. So over to the third option and hit enter so that that's highlighted. XList is just list 1. That's where my data is. If I had put it in list 2, then I would write list 2 there. Frequency is 1, meaning each entry in list 1 represents one individual observation. In other words, if a number happens twice, I type it in twice. This is all the way I want it, so I feel a little scared. I'm going to quit again. Especially if you're using this calculator in another class, you're going to want to make sure that everything in your regular Y equals plot is empty. So just scroll through these, make sure they're all empty. For example, if you're in pre-calc, there's going to come times in the year where you're graphing stuff a lot, and it's going to interfere with your graph. So just make sure your y equals are all empty. I'm scared again, so I quit. Now, how do I actually make this histogram show up? Well, I want you to hit the zoom key, zoom, which is the top middle, and then the number 9, zoom 9. And there's my histogram. It looks a little different than the one you made by hand yesterday because it chose different bin widths. Okay, these bins are different width than what you made. And you can actually see what they are if you hit trace. You can see that this bin went from 180 to 187.4. That's a horrible width. 7.4 is their width. You would never ever pick that ever, but the calculator chooses it in a way to spread the graph out in an appropriate way. And I see that I have one observation there, and if I hit the right key, 187.4 to 194.8 has one observation. 194.8 to 202.2 has two observations, and I can continue reading off the information from this graph. So now I'm scared, so I'm going to quit again, and it takes me to my home screen. And let's say I'd like to clear this data from my calculator. You don't have to. You can wait until you need it again, but I want to make sure everybody can do this. Go back to Stat and Edit, and now I want to clear this list, so go up so that that list is highlighted, and hit Clear, not Delete, but Clear, and Enter. Now, just while we're here, let's say somebody wasn't quite listening and they accidentally deleted list 1 instead. Don't do this unless you need to follow along. So now, oh no, Miss Kramer is not here because she went and had a baby and I lost list 1, so I'm pretty much going to fail AP Stats now. No, it's okay. Go up so that list 2 is highlighted, and I want you to hit second insert, which is the delete key, second insert. And now you have this blank list, and your calculator is asking what you'd like to name it. Well, I'd like to name it list 1, which you get by hitting second 1. So now I have list 1 back. It is no longer gone. And this will allow you to replace any list that you accidentally delete. Scared again, so I quit. And I'm going to return back to the PowerPoint. Here are a few more terms that I'd like to define, and then we're going to learn how to make yet another type of graphical display. So the first term is a frequency distribution. This is just a table displaying the different intervals, the different bins, and their frequencies or relative frequencies. You've made frequency tables already. You made one whenever you made the histogram yesterday. So that's what a frequency distribution. It's just showing how many observations fall into each bin. The term relative frequency is a silly fancy word that just means percent. Okay, so it converts each frequency into a percentage. So let's say that 0 to 10, 10 to 20, 20 to 30, and let's say their frequencies were 2, 3, and 0. That's boring, but 2, 3, and 0. If I were to convert those to relative frequencies, that would just be dividing by how many there are. So 2 now means 2 out of 5, or 40%. 3 means 60%, and 0 means 0%. So relative frequency, just a fancy word for percent. And then for cumulative relative frequency, well, I'm going to have to show you that via an example. And what I'm going to do is show you the graphical display of cumulative relative frequencies, which is called an ogive. Okay, so to talk about cumulative relative frequency, I'm going to use an example of how long it takes you to arrive at school in the morning. So from the door of your home to the door of Freedom High School, how many minutes does it take you to get here? And if I were there, I would get actual data from you all, and I would ask, how many people does it take 0 to 5 minutes, 5 to 10 minutes, and I would record your responses here in the frequency column, and it would be so much fun because you'd be like, oh my gosh, that's me in that box. But I'm not there, so I'm going to make it up. So let's say we have 5 people for whom it takes 0 to 5 minutes to get to school. I say, raise your hand if it takes you 0 to 5 minutes, and 5 people raise their hand. That's a frequency of 5. 5 to 10 minutes, let's say that's 4 people. And then 10 to 15 minutes, let's say that that's 6 people. And then 15 to 20, say that's 3 people. And then 20 to 25, oh no, nobody raises their hand. That's not anybody. And then let's say 25 to 30, I have 2 more people raise their hands. Okay, and let's say that's the entire class. And I calculate what this adds up to, and I believe it adds up to n equals 20. We have 20 observations represented here. Okay? So the next thing we need to do is calculate relative frequencies. Remember, those are just percents. So 5 people out of 20, 5 divided by 20, means that's going to be, what, 25%? And 4 out of 20 is going to be 20%. If you don't believe me, go ahead and calculate it. 6 people out of 20, I believe that's 30%. 3 people out of 20, that should be 15%. 0 people out of 20, that should be 0%. And 2 people out of 20, that should be 10%. And I kind of quickly add this up together, and it does add up to 100%, which is what it should add up to. Okay, that should all be stuff you already know. Let's talk about something called cumulative frequency. The root of the word cumulative is the same as the root of the word accumulate. So in other words, it's how many people have I accumulated by the time I finish this interval. So by the time I finish this first interval, I've accumulated 5 people. By the time I finish the second interval, I've accumulated those 5 people plus the 4 people that are involved in this interval. So by the end of 5 to 10, in other words, from 0 all the way to 10, I accumulate 9 people. On the next interval, 10 to 15, I get 6 more. So by the end of that interval, I've accumulated 15 people. Then 3 more, so my cumulative frequency is 18. My next bin, I don't accumulate anybody. So still, it's 18. It's not 0. I've accumulated 18 people by the end of this interval. And then I pick up the last 2, so that's 20. With this idea of cumulative frequencies and eventually cumulative relative frequencies, I want you to think about, it's appropriate for this problem, taking the bus to school, okay? On the bus, on the way to school, does the bus driver let people get off the bus? No, right? If you're on the bus on the way to school and if the bus stops and you say, you know what, I'd really rather not go to school today. I think I'll stop here because it's close to my friend's house. That bus driver is not going to let you get off the bus. So with cumulative frequency and in a second cumulative relative frequency, we only add people. If anything, maybe we stay the same. Nobody got on the bus at that stop, but we never go down. These numbers never go down. They go up or they stay the same. We're accumulating. So for cumulative relative frequency, that word relative just means percent. So you can either think of this as accumulating the percents or converting the cumulative frequencies into a percent. So for this first one, it's still just going to be 25%. For the second bin, 5 to 10, you can either think of it as the percent associated with 9, so 9 out of 20, or you can think of it as adding these 2 percents together, 45%. And notice that gives me the same thing. Then I add on the next 6 people and I land at 15, so that's 15 out of 20. Okay, or I can think of it as 75%. Again, same thing. I took the 45% that I had accumulated and I added the 30% that got on in that interval. So plus 15% lands me at 90%. Next interval, I don't accumulate anybody, still 90%. And then on the last interval, I pick up the last 10%, which leaves me with 100%, or I could have thought of it as 20 out of 20. Should always end at 100%. So an ogive, or a cumulative relative frequency graph. They're the same thing. You probably won't see that word ogive on the AP exam. They will probably call it a cumulative relative frequency plot. It's a graphical display of that last column, those cumulative relative frequencies. So on the x-axis is our quantitative variable, which in this case is travel time. I'm going to start at 0, 0 to 5, 5 to 10, 10 to 15, 15 to 20, and 20 to 25. I did not space that out very well. Oh, it did go up to 30, 25 to 30. And on the y-axis is the cumulative relative frequency. So that starts at 0 and needs to end at 100. Notice my axes are already labeled for me, and this is already written as percent. So I'm just going to write 10, 20, 30, 40, and so on. And then what I do is I plot these as points and I connect them with line segments. So at 0, I start at the coordinate 0, 0. By the time I get to 5, I hit accumulated 25%. So I'm going to do my best and draw a dot here at about 25 and connect those dots with a line. By the time I get to 10, I've accumulated 45%. I'm just taking this off of the previous slide that we generated together. By 15, I'm at 75%, so that's right about here. 20 puts me at 90%. 25, I maintained at 90%. And then 30 finished out at 100%. So I'd like you to think about what this horizontal segment means. What it means is that nobody belonged to that interval. In context, that means it took 0 people 20 to 25 minutes to get to school. So that horizontal one doesn't mean it took the same number of people or something like that. It means it took 0 people that amount of time. Nobody got on the bus at that bus stop, if that makes sense. So what is more likely than having to create an ogive is interpreting an ogive. Okay, so here's one. It has for presidents, U.S. presidents, their age at inauguration, and the relative cumulative frequency associated with that age. So I want you to look at these 3 questions, and we're going to try and answer them together. The first one says, what percent of presidents were inaugurated at age 50 or younger? In other words, by the time I get to the age 50 bus stop, what percent of presidents have I accumulated? Well, I'm going to look at 50 on the x-axis. I'm going to trace up until I get to the graph. And I'm going to trace to the left until I hit the y-axis. And it's a little bit less than 20%. I think I'm going to call that about 18%. Okay, so what that means is that 18% of presidents were inaugurated at age 50 or younger. The next question says, what age corresponds to the 50th percentile? This is a little tricky because we haven't learned this word percentile yet. But the word percentile means what percent of observations are this number or less. Okay, if you take a test and you score in the 95th percentile, that means 95% of people got your score or lower. Well, percentile is really the same thing as cumulative relative frequency. In other words, at what bus stop have I picked up 50% of the people by the time I get there? So I'm going to look at 50 on the y-axis and trace it over and down. And fortunately, it's pretty exact. It looks like about 55 years. So 50% of presidents are 55 years old or younger. I'd like to point out that that's the median. It's the midpoint. At 55 years, half of presidents were inaugurated younger than that, and half of presidents were inaugurated at an age older than that. So 50th percentile is the same thing as the median. Last question, what percent of presidents were inaugurated between the ages of 50 and 60? I want you to think about how to do that. Okay, so I already know that 18% of presidents were inaugurated at age 50 or less. If I do the same with 60, if I trace 60 up and over, oh, I started off well. It's probably about, I don't know, about 78%, let's call it. Don't worry too much about accuracy here as long as you're in the right ballpark. So if 78% of presidents were inaugurated at age 60 or less, and 18% were inaugurated at age 50 or less, then the percent that fall between these two must just be the amount that the graph went up between those two. In other words, the difference of the y values. So 78-ish minus 18-ish gives me 60%. So about 60% of presidents were inaugurated between those two ages. And I got that by subtracting the y values. I'd like for you to try an example. And so this ogive shows the number of hours worked per week by a certain set of workers. And on the y-axis, again, is the cumulative relative frequency. And I'd like you to answer these three questions. What percent of people worked between 40 and 45 hours? What is the first quartile, also known as the 25th percentile of this distribution? And what percent of people worked between 45 and 50 hours? Please pause the video for 5 minutes and allow students to answer these three questions. Okay, so between 40 and 45 hours, that's between these two. So I'm going to trace up 40 and I'm going to trace up 45 and I'm going to find the difference between their two y values. So that would be 50 and approximately 25. So 50 minus 25 is 25% of people worked between 40 and 50 hours. For the first quartile of this distribution, in other words, the 25th percentile, I'm going to locate 25 on the y-axis. I want to know what percent, or for what number of hours 25% of people work that amount or less. So I'm going to trace that over and down, and I kind of already found that it was 40 hours. So 25% of people worked 40 hours or less. I'm going to write that out. That or less is key. What percent of people work between 45 and 50 hours? Well, I notice that between 45 and 50, the line is horizontal. The answer is not 50%. What's the answer? 0%. I did not accumulate anybody between 45 and 50. This is kind of like slope, right? The slope is 0. We did not accumulate anybody. Last quick graph that I'd like to show you is a time plot. This is one that's not heavily emphasized on the AP exam, but I'd like it to show it to you anyway. It plots the observations on the y-axis. So whatever my variable is actually goes on the y-axis. And on the x-axis is time. This is a funny one. It's got 3 different lines represented. Usually you just see like one going like that. And it emphasizes trends over time. So what I think of when I think of a time plot is like a CEO standing in front of the boardroom showing how profits are steadily going up or going down or whatever they're doing over time. So again, the x-axis is time and the y-axis is some variable that I'm measuring. I plot the points and usually connect them with straight line segments. That's it for today's lesson. So here is homework assignment number 2. I want to tell you again, this is due the day of the Chapter 1 test, but I strongly encourage you to do it tonight. This starts on page 64, but it's going to cross over onto other pages. Remember, don't worry about whether you're doing the correct number 26, as long as it starts with a 1, 1.26. That means Chapter 1, problem number 26. So you're doing 13, 16, and 26. If homework number 1 took you less than a full sheet of paper, by all means, you could start homework number 2 within that same sheet, but do please make sure you're leaving enough space and doing these well. Thank you. And